A few weeks ago, Q.ANT, a photonic AI chip company based in Stuttgart, Germany, announced a new pilot line capable of producing 1,000 wafers a year. So joining me to explain why their approach could be a potential rival to Nvidia is Michael Förtsch. Michael, please explain what you're doing to revolutionize the data center market and why your approach is different.
Hi, thanks for the opportunity. So I think that the most important difference to a regular graphic card is that our core is working light-based. So the core chip is a thin-film lithium niobate chip, and this allows us to compute analog. And I think that's the main difference to all the other cards out there. That the core allows us to execute analogically very complicated mathematical functions without digitalizing them. Now, this dream has been in the industry for decades, I would say. The huge thing that we accomplished thanks to lithium niobate is that we met the accuracy requirements. So we can execute on a 16-bit floating point precision on an analog computer. And this was the breakthrough, actually, to make such a technology valuable in the compute infrastructure.
You've invested 14 million in a pilot line. Why is this move critical, and why do you need this upscaling so quickly?
Because of quality. So when we started with thin-film lithium niobate already in 2018, right? But back then, basically, our wafers were passengers through the world. We manufactured the individual process steps all around the world together with partners. But of course, whenever a wafer leaves a clean room and goes into a clean room again, there is always a potential contamination issue. And by deciding already in 2022 that we are building the first pilot line, we were highly convinced that this is going to push the quality of the wafer production or the chip production dramatically. And this is exactly what we see.
14 million is, of course, a lot of money, but how does this investment compare to what's really needed for scaling up?
The great thing is, I mean, 10 million for a startup is huge. In comparison to what a chip pilot line usually costs, it's comparatively cheap. And what we accomplished here together with the IMS CHIPS is we took a CMOS foundry from the 90s and we repurposed it for photonic chips. So most of the tools that we are using have been in the foundry for years, and we only strategically replaced a few tools at the amount of 10 million. And this only because of cross-contamination, right? Lithium niobate is not silicon. That's the reason that some tools in the line need to be dedicated to the material. And this is the reason for the 10 million investment.
Nvidia dominates AI and HPC with GPUs. We are all really excited about Jensen's presentation 2 weeks ago. Why is thin-film lithium niobate the material that can challenge Nvidia's silicon-based approach?
Well, first we need to separate Nvidia. Even today, I mean, they are still using CMOS-based GPUs. So at the core, we are computing completely different. Now, what in addition brings a lot of features. So first of all, we can get a very high computational density, especially on the functions required for AI. Second, light is propagating along the chip. You don't need to push it, right? Once injected into the chip, it's just floating. And when we come to the features of thin-film lithium niobate, in contrast to silicon in the context of photonics, there are two fundamental advantages. The first one is I can control the light without electricity on the photonics layer, meaning there is no electricity, there is no heat, there is no heat dissipation. You can modulate the signals very clean. This is the one important ingredient. And the second one, lithium niobate allows you to modulate your signals in the gigahertz range. So by that, we have a very fast switching mechanism or a processing speed inside the photonic core. And these are two things you're going never to, they're unreachable with a silicon architecture in the context of photonics.
This is a really good point. Yes, in this, Nvidia is using still CMOS for all the computing part. GPUs have become indispensable for AI model training and interference. Can photonics, in your opinion, truly replace GPUs in AI and HPC, or is it just a niche accelerator?
Well, for the moment, I would say we should start in the niche. Because we are basically seeing that we can take, for instance, replace dedicated functions highly efficient and ultimately fast in contrast to a GPU. But we have a roadmap where we grow also the applications that are executable on a photonic architecture. Now, if I envision in 7 to 10 years a data center infrastructure, I would assume that photonic accelerators, like those we are building, can take 50 to 60% of the jobs of a GPU in the context of AI. Um, Saying that, this also explains we can't do every job a GPU can do, but those, especially in the context of AI, we can do better and more energy efficient.
Let's talk about AI. I love AI. So it is not only about the hardware, it's also the software. And Nvidia owns a complete software and hardware ecosystem. We talk about CUDA, AI frameworks like TensorFlow and PyTorch, really optimized for GPU. So let's talk about Q.ANT and adoptions plan. What's Q.ANT's strategy to ensure software compatibility and convince developers to build for photonic processing?
Yeah, this was something where we have been thinking very thoroughly about. And what we can proudly say, so first of all, the photonic processor comes on a standard x86 interface. So we choose PCI Express to an x86 interface. This on the one side makes it truly compatible from the data throughput side. The second one, and this was a development criteria, we wanted that this technology is fully compatible with the high-level programming languages and libraries, like you mentioned them, PyTorch, TensorFlow, and so on. So once you have one of our cards, you can use your existing source code, and we give you the driver anti-compiler architecture in addition, so that our system can be seamlessly integrated into the data center infrastructure. Saying that, true, Nvidia is very strong on the software side, but we see that the opportunities that we are offering opens also a great opportunity to basically allow for additional software stacks, because when you conclude it on a card level, we're 50 times faster and 30 times more energy efficient. If you go on the full server rack, this piles up to an advantage of 100 times more data throughput and 90 times less energy consumption. And I think when you see these extreme numbers, which are becoming within reach with photonics computing, then this also allows for fundamental change also on the software side.
Let's talk about early adopters of your platform. Could you describe some real-world use cases where photonic computing already outperforms silicon?
As of today, we are mainly focusing on dedicated functions. So I give you one example. It's the Fourier transformation. If you execute the Fourier transformation on a CMOS-based architecture, it takes millions of transistors, while on the optics, it's one single component. So whenever the algorithm is basically inherently making use of Fourier transformations, photonics already today can give you an advantage in comparison to the CMOS architecture. As we grow the architecture on the course of the next years, and applications based on Fourier, but also on other basic functions becoming much and much faster than the CMOS architecture. We are currently talking, for instance, about weather forecasting simulations. So everything that's in the category physics simulation based on Hamiltonians and for instance, partial differential equations, great for photonics. If you incorporate sine and cosine functions, great for the photonics architecture. If you have complex numbers, great for the photonics architecture. If it's an exponential function, as we said, great for the photonics architecture. So to give you a bit of an imagine what can become true, we are working on operating on a fully homomorphic encrypted space using Fourier transformation functions. We're working on text to image with alternative algorithms than are currently used with a GPU, allowing us to be much faster in the future. Not today, in the future. And ultimately, the target is to go text to video. So imagine you're typing in a text and you're getting your video back. That's the core application or the key application we're outlining within the next 5 years.
Let's look into the future. Let's play the crystal ball game. It is 2030, and you and me are having this conversation. Will photonic processors power the biggest AI models now? And how does your company Q.ANT look like?
Well, that's the question I like most. Yes, by 2030, photonic processors have become an integral part of every AI-focused data center in the world. We are basically the technology that open up doors to these more advanced AI models. We're not talking about large language models. We are more talking about text to video, text to image, text to text, speech conversation in real time. We are talking about weather forecasting, aerodynamic simulations. We're talking about whatever, right? So all these things that are from the mathematical point of view rather complicated, but would gain a lot of industry traction. This is where photonics and photonic coprocessors come into play.
Let's finish with the Optica question. What can other corporate members do for Q.ANT, and what can Q.ANT do for them?
Well, we actively search for companies that are supporting us on our mission to basically bring photonic accelerators to a large-scale product. So whenever it comes to photonic integration, components, laser diodes, detectors, integrating into semiconductor platforms, please dial my number. So we have to improve the system. We have to mature it. The end vision shall be that you have a photonic chip and you can bring it onto a board as simple as you can do it today with electronics. That's the ultimate vision. Once we reach that goal, there is no stopping of photonics in the future. Now, what we can bring to others, contact us if you're interested in Thin-Film Lithium Niobate technology. I mean, we have a pilot line operating and we currently use it for photonic accelerators, but photonic integrated circuits can do much more. This is a different business which we are not pursuing, but if you're interested in, just contact us.
Michael, congratulations on everything that you are achieving. I look forward to coming to visit you in Stuttgart and make a video of your facilities over there. All the best. Thank you.